our fabulous chemistry minions.
Our fourth video.
Yeah, who are you?
I'm MoNaCo.
Oh, yeah. And I'm Milks. Fourth video, pages.
11, 12, and 13. So we're going to try and get through this one kind of quick.
Ooh.
Because there's a lot of material. So we're going to kind of be less on the air.
Ooh, okay. We got to do some writing.
What's a half reaction? That's our goal here. So you got to be able to find a redox reaction.
Right.
There's 3 tricks.
Right. Well, first of all, if there's a metal in a single replacement reaction,
It's redox.
it's redox.
Period. Second trick, if there's metals in double replacement or there's no element by itself, pure.
No redox.
No redox. This is just a shuffling of ions. It's a double replacement. It is not a redox.
Right.
The third point and part is that we are going to be treating it this way. Many redox reactions have spectator ions. They do not get involved in the transfer of electrons. They're just kind of there holding places.
Right.
What ion here is the spectator, Mr. Milks?
Well, I want to go back real quick just to the first part, and we'll go right through it. Ready? We know from what we learned last video, Fe is going to be a charge of 0, and Ag is going to be a charge of 0.
So there's a metal, and
Right.
it looks like it got replaced into the compound.
I don't know right away, but this Ag is going to have a number, and this Fe is going to have a number, and that's how we know we have a redox.
Now, the part that I'm talking about right here is that NO3 part, because it does not get involved with the redox. That chunk, NO3, it is not part of redox itself. It's a spectator.
Right.
It's there because it has to be there for the balance of ions in the compound and stuff, but it itself is not going to be involved in the transfer of electrons.
Correct.
So we already know that the transfer of electrons in this scenario is going to be between iron, Fe, and silver, Ag.
There you go. One will be oxidized, one will be reduced, and I'm not going to do it right here because we're going to figure that out.
Keep on keeping on.
That's right.
So identify the elements that are oxidized and reduced is the key. So
Here we go.
Mr. Milks is up at the board. He picks up the black pen, and he identifies the elements that are by themselves in the pure state and gives them oxidation state 0. Because
Right
that's
off
the
the bat.
rule. Then he goes and does a little algebra and figures out that Ag, silver, has only one option on the periodic table. It's got to be +1. Now iron, Fe, has got 2 options on the periodic table. And since we know our polyatomic ions so well, we know that iron's got to be the +2. Because there's 2 nitrates, nitrates are -1 charge, and so we're going to go ahead and circle the +2 and erase the rest of that scratch.
You got it.
Because we found the elements that are oxidized and reduced. We know what we're going to be playing games with. So iron 0 is going to become iron +2, and in the process, releasing 2 electrons.
Notice they are on which side of the arrow?
Right-hand side, product side. They produced, lost 2 electrons. Silver, Ag, is in the +1 state, and there's 2 of them. Then we're going to add 2 electrons to get them into the 0 state, 2 Ag zeros. Mr. Milks just drew you both a redox and, an oxidation and reduction half reactions, because both of these together are happening at the same time to make the whole redox reaction.
Correct. And remember, redox is just short for oxidation and reduction. We do say it really quick like that too, right?
Redox.
Yes.
So that top one, Fe, iron becoming iron +2 and 2 electrons, is that oxidation or reduction?
Well, let's just look. Is he gaining electrons or losing? If
Lost
he's on the product
some
side, he's
electrons.
losing. So let me go back. Oil rig. Losing is oil. Oxidation.
Lose electrons, oxidation. Oxidation.
So the ox is here.
And that leaves the other one's got to be
Yeah,
reduction.
rig, gaining, and then so that's in the reactant side.
Reduction.
So that will rig.
Yeah,
Reduction.
reduction. R-E-D, reduction.
Got it. I wrote it in green though.
So here's a couple other examples where we're going to do the same exact thing.
Go ahead, you can jump to the board.
I'm going to find my elements that are pure first.
Yep, so let's do that. Let's do the ones that are 0 first. I like to do that because those are easy. Okay? And then copper has some choices, but we're going to use what we know about chlorine to backtrack. And ZN doesn't have any choices, but we can still backtrack.
So I'm going to erase my chicken scratch.
And I know we did that fast, but I hope you guys understand. 2 negative ones is a -2, and therefore I need a +2. This really is a little bit of review from bonding. Now, he's got a Zn0 going to a Zn +2 and giving off 2 electrons. He has a copper +2 gaining 2 electrons and going to copper 0. This will happen simultaneously. They are equal and they are opposite. And when we say equal, 2 electrons.
The 2 electrons that zinc lost are the 2 electrons that copper gained.
Correct.
They're the same ones.
Correct. And you could actually go ahead now and rewrite that.
If you wanted to, you'd throw the electrons out of the picture, and it would be
The actual and the spectator ions out of the picture.
Do you want me to put that? Do you want me to put it up there?
No, I think we can just say it
Okay.
because it's pretty easy then. Because you're just going to add
Pure
two
metal
equations.
zinc plus a
Copper
copper
+2
+2 ion becomes
Cn +2 plus copper 0. Perfect.
Nice.
We
Last
got
example,
one more.
with some spectator ions involved.
Right. The spectators are here, but we don't write the spectators when we put them two together. So again, let's get in the habit. Let's do the zeros first, the metals by themselves.
Yep.
I know that sulfate is a -2, so the Mg must be a +2. And that's going to be on both sides, the spectator ion. So that's going to be a -2 also. So I know the Mg is going to be a positive, or the copper is going to be a +2. And what's nice about the Mg is he only has the one choice anyways. Copper does have two choices. So that's where the sulfate ion helps guide us to pick the +1 and not the +2. Now we can rewrite these. I have Mg0 going to Mg +2 plus 2 electrons. And I have copper +2 plus those same 2 electrons becoming copper 0. Now that is us writing the half reactions, and pretty quick, I must say. And now we're going to go ahead and get a little practice saying oxidation and reduction, because again, oil rig, oxidation is losing, reduction is gaining. Now, I'm going to give you guys a little hint. When I sit down to do these practice pages, you better believe I'm going to write oil rig on the top of the page, and I'm still going to do it, because I don't want to have to think too much on that stuff. You know what I'm saying?
Okay.
So, the overall half reaction shows
Atoms that gain and lose electrons, and the number of electrons involved.
right, spectator ions are gone.
Yep.
Basically. Quick half reaction.
Atom or ion gains electrons and the number of electrons.
Now we just drew that on the last page. We drew both half reactions. This is just the reduction half reaction.
This is going to happen in 1/2 of our batteries that we're going to look on later.
Right.
That's why we split them up in halves.
Correct. And then the oxidation is just the atom or ion losing electrons and the number of electrons that it lost.
Now MoNaCo's least favorite part
All right,
of the
you
unit.
take a break, I'll do it.
Yeah.
All right. So the oxidizing agent it's the thing that is responsible for the oxidation. Hence, it is the thing being reduced. If oxidation is losing electrons, the oxidizing agent is the dude gaining the electrons. He's responsible for the loser losing his electrons. He was the one that said, give me them, give me them.
Right. And for MoNaCo, this is just a mind screw. So you have to
It
pay
is.
real close attention to Mr. Milks.
I understand that it's really like doing too much, but unfortunately,
It's
a
testable.
New York State thing, and it's on every test. So the exact opposite. The reducing agent is the thing that's responsible for the reduction. Hence, it is oxidized. The guy that's losing electrons makes it possible for the reduction to happen. Okay? Now we got some examples.
Same ones that we saw before.
A lot of them, yes. So let's
Actually,
go
we
ahead and...
just did this one.
Oh, did we?
Yeah. You and I,
Oh.
we wrote it on the board volunteering.
Ooh.
Here's how you're going to see it in your practice.
Okay, are we going to do it quicker?
Yeah.
All right, so again, let's go ahead and assign the zeros first, because that's the easiest. On our lone metals. And then Cl is a -1 all the time, so I get a total -2 charge, which means I need a +2 charge. And now I can do just the oxidation reaction. Now, what you need to remember is oxidation is losing. So I got to remember that going from Mg0 to Mg +2 is the oxidation. The other one is the reduction. Notice I go from +2 to 0. My charge is being reduced.
So for me, the reducing agent, reduction is gaining.
Reduction is
Whatever
gaining.
allows something to gain the electrons is the reducing agent.
Right, it's the other guy.
So it's Mg,
Wait,
0.
Mg is being oxidized, so it is the reducing agent.
And so Mg elemental 0 is the agent.
Correct.
And therefore, the oxidizing agent, you got to tell me about it.
It's the +2.
The same +2?
Yeah, the agents are always reactants.
Okay.
Yes,
Okay.
the agents are definitely the
Power 2, I'm
reactants,
glad
man.
you
Well,
know
think
that.
about it. The Cn +2 is the one that's gaining the electrons, not the Cn0.
Right.
If the Cn0 is gaining electrons, he'd be a Cn -2. And he's not. So the Cn
Couple more
+2.
examples.
All right, again, let's label up our metals with their zeros because they're all by themselves. They're the easiest. I know chlorine's a -1, so silver's a +1. And also mercury is going to now be a +1. I have mercury 0 going to mercury +1 and 1 electron. I have Ag +1 gaining 1 electron, becoming Ag0. So now, the oxidation is the reducing agent, so Hg0. And again, the reduction is the oxidizing agent, Ag +1.
Did I get it right that
You
time?
got it right that time.
Something I'm thinking in the top of my head is the element that's pure metal and an oxidation state of 0 is your reducing agent.
Yep.
And the element on the left-hand side of our arrow that ends up as the 0 on the right-hand side is the oxidizing agent.
If that helps you figure it out,
It's kind of a backwards trick, but that's how I got those ones so quick right now.
okay, good.
Just because Mr. Mills taught me.
Hey, let's do one more example and we're done. Ready? So again, copper and silver by itself, we'll give them our zeros. I know NO3 is a -1
Why did I cross it off?
because it's the spectator ion. One thing that we're going to find is that these guys do not polyatomic. That's a +2.
It is.
Yeah, this one isn't
Two.
Yeah, this one isn't properly balanced, but that's okay.
Isn't it? No,
Well, that's okay.
it's not.
Because the 2 in front of the copper doesn't change the charge on the copper. So you'll find that these things aren't always properly balanced. A lot of times we find them just like this. Okay?
Now they are.
Yeah.
Now it is.
Yeah, but that doesn't change anything. So, and we don't put in coefficients so much here sometimes unless we need to. All right, so again, copper 0 plus, or goes to copper +2 and +2 electrons. Ag +1 plus 1 electron goes to Ag0. And this is where, given the opportunity, we would have to, and I want to take the time to do this. I see the difference between 2 electrons on one side and 1 electrons on the other side.
So what do I need to do, Mr. Mills?
I need to take that reduction reaction and multiply the whole thing by 2, and then rewrite 2Ag +1 plus 2 electrons goes to 2Ag0. And now I've balanced my redox reactions so that my electrons can cancel.
Because remember, if you lose 2 electrons,
gotta
somebody
gain.
else has got to gain 2
Yeah,
electrons.
not 1.
Even if it's 2 other things gaining 1 each.
Sure.
That's why we just multiplied by 2. Because silver can only take 1.
So
but there's
much-
2 to give. You got to double the amount of silver involved.
Right. Again, kind of like a little bit of a review from redox or from bonding back in the day.
Moses stoichiometry.
Yeah, that too. Yeah.
Balancing equation.
Ready? I think. Oh, we got to summarize.
Mutual and simultaneous.
Yeah, and equal. The half reactions. Can we write one where it's an oxidation, write a separate one where it's a reduction? That's what we need to be able to do.
Yep. Split the reaction. Look at the big reaction. Identify the oxidation and the reduction that's occurring within it. Ignoring the spectator ions. That's also really important.
Yes, it is. Isn't that great that it's important to ignore something?
Yeah, love it.
Love it.
Pay no attention to the man
But
behind the curtain.
here the key is, and notice, during one of these half reactions, the electrons are on the right-hand side.
And
on the other ones, they're on the left-hand side. Because
kinda
one's
goes
gained,
back
one's
to your
lost.
Oil rig.
There we go.
So thanks for watching. It was a little bit longer. Lots of practice on this one.
Yeah, this is it. This is one of the major things we need to be able to
Meat
do
and
for the show.
potatoes.
That's it. So again, do lots of practice and ask lots of questions if you need help.